Hey everyone, welcome to Pythonic Pioneer. This will be part 2 of our revisions series, and the topic today is graphs. I will be revising along with all of you guys, so let's get pumped up and ready to revise some code. What are graphs? Graphs are fundamental data structures in computer science and have a wide range of applications, including modeling networks, social relationships, transportation systems, and more. Let's start with the introduction to graphs, their types, and basic terminology. A graph is a data structure that consists of a fine set of vertices or nodes connected by edges. Each edge connects two vertices and may have an associated weight or cost. Graphs can represent various relationships between objects or entities. Again, a graph is a data structure that consists of a finite set of vertices or nodes connected by edges. Each edge connects two vertices and may have an associated weight or cost. Graphs can represent various relationships between objects or entities. Types of graphs. There are several types of graphs, which include undirected graph, directed graph, weighted graph, cyclic graph, and an acyclic graph. Coming to an undirected graph, in an undirected graph, edges have no direction. There is an edge between vertex A and vertex B. You can travel from A to B or B to A. Directed graph. In a directed graph, edges have direction. If there is an edge from vertex A to vertex B, you can travel from A to B but not from B to A unless there is a separate edge in that direction. Weighted graph. In a weighted graph, each edge has an associated weight or cost which can represent distances, costs, or any other measure. Cyclic graph. A cyclic graph contains at least one cycle, a path that starts and ends at the same vertex. A cyclic graph, a directed graph with no cycles, DHGs are used in various algorithms and applications. Basic graph terminology. Here are some fundamental terms used in graph theory. Vertex node. A fundamental unit in a graph. It represents an entity. Each vertex can have a unique identifier, edge. A connection between two vertices, edges can be directed with a specific direction or undirected without a direction. Adjacency, two vertices are adjacent if they are connected by an edge. Degree, the degree of a vertex is the number of edges connected to it. In an directed graph, there are two types of degrees, in degree, incoming edges, and out degree, outgoing edges. Path. A path is a graph in a sequence of vertices where each adjacent pair is connected by an edge. Cycle. A cycle is a path that starts and ends at the same vertex. Connected graph. A graph is connected if there is a path between any pair of vertices. Component. If in a graph, a component is a subgraph in which any two vertices are connected to each other by paths. How would you represent graphs? There are two data structures, mainly adjacency matrix, a two-dimensional array where each cell ij represents whether there is an edge between vertex I and vertex j. For weighted graphs, the cell can also store the edge weight. Adjacency list. For each vertex, store a list of adjacency vertices. It's a more space-efficient representation for sparse graphs. Also, if there is a weight associated, then it can store a tuple instead of a list of tuples. Graph algorithms. There are numerous algorithms and problems related to graphs, including graph traversal. Techniques like depth first search and breadth first search are used to explore and visit vertices and edges in a graph. Shortest path algorithms. Dijkstra algorithm and Bellman-Ford algorithm are used to find the shortest path between two vertices in a weighted graphs. Minimum spanning tree MST algorithms like Prim's and Kruskal's are used to find the minimum spanning tree in a graph. Topological sorting. This is used on directed acyclic graphs to order the vertices in a way that represents the direction of edges. Graph coloring, solving problems relating to coloring of vertices or edges of a graph subject to certain constraints. Maximum flow, algorithms like Ford-Fulkerson used to find maximum flow in a flow network. Graph algorithms in social networks. Graphs are used extensively in social network analysis, recommendation systems, and community detection. To get started with graphs, it's a good idea to implement some basic algorithms, create graph visualizations, and practicing solving graph-related problems. You can use programming languages like Python to work with graphs, using libraries like NetworkX, or implement graph data structures from scratch. So that was it for this article. Feel free to leave some questions or comments, and I'll be back with the next video explaining these graph traversal algorithms. Thanks for watching. Have a great day.